Welcome back to your next video, this one on solving linear equations. The basic objective when we solve linear equations is to find the value of the unknown that will make the equation true. How do we do that? We perform inverse operations to isolate the unknown. You've all done this before. We do the same thing to each side of the equation until we get that letter on its own and we're all done. First example here, 3x plus 4 equals 12. Two choices here. Do I divide by 3 or subtract the 4? A good rule of thumb is to always get rid of whatever has the least amount to do with your variable first. In this case, the 3 is sort of joined to the x, the 4 is a little add-on, so I'm going to get rid of that first. So the opposite of adding 4 is to subtract 4 from each side. That leaves me with 3x. Little equivalent sign, just keep myself organised. 3x equals 8. Last step. The opposite of multiplying by 3, to divide by 3. So I divide each side by 3. Remember, whatever we do to one side, we do to the other. When I divide each side by 3, I've got x equals 8/3. Leave your answer as fractions. We don't like decimal approximations unless we have to have them. And improper fractions are preferred to mixed numbers. Unless you're given an equation where you start with mixed numbers, I would always leave mine with improper fractions. Next two equations, very similar. Both got 5 in front of a bracket. The difference is the number on the right hand side and actually the symbol in the bracket too. But the key is this number in the front in the first place, that 5, is a factor of 20, and in the second one it is not. In general, if it is a factor of the number on the right, rather than expanding that bracket, what you want to do is make your life easy. The opposite of multiplying by 5 is to divide by 5. If I do that to each side right now, I'm going to be left with x minus 3 equals, and 20 divided by 5 is 4. Pretty obvious now what to do. Add 3 to each side. That's the opposite of subtracting 3. And therefore we've got x equals 7. Remember, you can always check by substituting in. 7 minus 3 is 4. 5 times 4 is 20. So you know you've got it right. Next question we've got here. 5 is not a factor of that negative 3. Although you could divide by 5, it would probably cause problems for you by introducing fractions earlier than you'd like to. So instead I'm going to expand my bracket. 5 times x is 5x, and 5 by 3 is 15. So I have 5x plus 15 equals negative 3. Now we're back to the situation that we had in the very first one. Nice easy one to solve. Opposite of adding 15, subtract 15. So I've got 5x equals negative 18. Opposite of multiplying by 5 is to divide by 5. So I divide each side by 5. And I've obtained my answer. X equals negative 18 over 5. A few more to go. Nasty ones where we have rational numbers involved. Rational coefficients, it's looking a bit ugly. My recommendation to you is to make this look as simple as possible as quickly as you can. In general, we are not as good at arithmetic with algebra, with fractions, as we are with whole numbers and integers. So look for the lowest common denominator. 3 and 5 both go into 15. I'm going to multiply each term in that equation by 15. When I multiply the 3/5 by 15, the 5 will cancel with the factor of 5 and 15 to leave me with 9x. 15 by 4 is 60. And when I multiply 2/3 by 15, the 3's cancel, and I'm left with 10 there. I now simply complete them the same way I have all the others. I've made it into a nice simple equation in one step. This will save you a lot of time rather than mucking around finding fractions on each side and doing all sorts of crazy things that I've seen students do over the years. So 9x equals negative 50. Final step, divide each side by 9. And I've got my answer. X equals negative 50 over 9. Same thing again, except this time we've got 3 different numbers in the denominator. You'll see they're all factors of 12 though. So simply multiplying by 12 is going to be the quickest way to get this into a nice simple equation to solve. 12 multiplied by m over 4. 4 is a factor of 12, so that would leave me with 3m. 3 is a factor of 12, so when I multiply the negative 4/3 by 12, the 3's cancel, and I've got negative 4 times 4 is 16. Finally, on the right-hand side of the equation there, 6 is also a factor of 12. It goes into it twice, so 7 by 2 is 14. Wow, doesn't that look nicer? Now it becomes really simple. Add the 16. And I'm left with 3m equals 30. Final step, divide by 3. And I've got m equals 10. Last one I want to talk about. If you've got a variable on each side of the equation, in this case I must expand first, 3p plus 6 equals 2p plus 10. Then it's just a matter of collecting your variables on one side of the equation and everything else on the other. 2 is smaller than 3, so I'm going to get rid of that. The reason I want to get rid of the 2 is so that I end up with a positive coefficient for p. If I'm getting my p's on the left, I'm going to get everything else on the right, so I'm also going to subtract 6 from each side. 3p minus 2p is just p on the left. The 6's have cancelled, and on the right hand side I've got p equals 4. That should be enough for a quick refresher. Good luck. Cheers.